Today we will discuss very basic theorem of the network analysis, and that is known as the superposition theorem. That means firstly we have to learn what do you mean by superposition. And the superposition is nothing, just we want to apply the linearity on my system. That means what do you mean by linearity? Linearity meaning that means any system will consist only the linear components, and the linearity principle they must have to follow. And the linearity principle is basically the summation of two type of properties. That means two type of principle involved in the linearity principle. That means first one is homogeneity and the second one is additivity. Additivity. That means, what do you mean by homogeneity principle? Homogeneity means if your system have the response y corresponding to any input x. That means if your input is x, which is producing the output of y. That means this is your input-output relationship, and if you will multiply your input by x amount any scale factor constant value, that means you are scaling your input with any constant scalar factor. That means if the system is following the homogeneity principle, output will also get multiplied or scaled by the same constant scale factor. And if it is happening in the system, that means the system is homogeneous. That means the system will allow the homogeneity principle to happen in the system. That means if your circuit is okay with this, that means the circuit is following the homogeneity principle. And corresponding, if I am multiplying with any other constant factor, the output must have to be multiplied by same factor as I have scaled my input. That means here I have scaled my input by a factor of b. At the same time my output must have to multiply by factor b. If it is happening, that means my system is homogeneous. Now take the another case. If I am applying a plus b in my system like as x, and if I am getting the system a y plus b y, which is the addition of individual outputs whenever I am placing like this. That means if I will provide the combination of input in my system, output must have to be summation of individual outputs corresponding to the inputs. That means this AY is a separate output when only this is my input. This BY is a separate output when BX is my input. And whenever I will put summation of these here, output must have to be individual summation of these outputs. And if your system is following this, that means this is my additivity principle. Additivity. Now, if my system is following homogeneity as well as the additivity principle, then only you can claim that your system is linear. That means your circuit is linear. That means your circuit must have to satisfy homogeneity as well as the additivity at a time, then only your circuit will become linear. That means we have to follow the linearity principle to apply the superposition. And whenever I will apply the superposition, I have to take care about the circuit component must have to be linear. Otherwise, the superposition theorem will not valid there. That means the first requirement to apply the superposition is all the component must have to be linear. Linearity means they will satisfy the homogeneity principle as well as the additivity principle. Then only I can apply the superposition principle. That is my first requirement to apply the superposition principle. Now that means the superposition we will apply in the circuit. But how to apply the superposition principle in the circuit? The statement of the superposition is the output response that means whether the voltage across the component or the current through the component, must have to be equal to the individual output summation. That means you will sum the individual output corresponding to each input. That is my superposition principle. That means we will define these things with the corresponding of the circuits. That means if you have any circuit like this, here I have one current source, and if I have one voltage source here, V, and this is my corresponding current, that means R1, R2 and R3. Here it is my entire circuit, and I want to calculate the voltage across this V. Now I want to apply the superposition principle. That means the first thing is homogeneity. Homogeneity means homo. Only one source can act at a time. That means if only one source can act, what is the meaning of this? That means I have to replace all other sources with their internal impedances. That means whenever you will apply this source, any other source is not allowed. Which type of source? Only independent sources are not allowed on that time. That means dependent sources are allowed to work. That means whenever you will apply this independent source, any other independent source is not allowed in my network. That means whenever you will replace the current source by internal impedance, we know the internal impedance of the current source is infinity. That means Rs is equals to infinity for current source. And Rs equals to infinity means open circuited. And the Rs of voltage source is 0. That means short circuited. That means whenever we will replace the current source, we will replace by open circuited. And whenever we will replace the voltage source, we will replace with the short circuit. Because homogeneity means only one source, one independent source can act at a time. That means my first source is voltage. That means the case 1, when voltage source will act. Source is active. That means I will replace this current source by their internal impedance. That means I will draw the entire circuit and I will replace this current source by its internal impedance. This is V, this is R1, this is R2 and this is R3. Now here, this is open circuited, that means no current will go here. That means basically this R1 and R2 now in series, and we want to calculate the V here, and I am assuming that whenever this voltage source is acting, voltage is V1 here. That means I can apply the voltage division across these two series components. That means the V dash is equals to R2 divided by R1 plus R2 into V. This is my first voltage just because of this voltage source. That means homogeneity I have applied only for this voltage source first. Then I will apply the homogeneity for the second one. Now, case 2. When current source is acting. That means again I will replace this voltage source by its internal impedance. That means the voltage source have the internal resistance of 0. That means short circuited. And entire circuit I will draw again. Now, here the current is I with the current source, and here we have two resistances are in parallel. That means we can apply the current division rule here. Here we can apply the current division rule. That means I want to calculate the current here. I am assuming that the current is small I. The current small I will be R1 divided by R1 plus R2. Now into the total supply current I. We not have to think any other, just we have to apply the homogeneity in the first attempt. That means this is the current here and the voltage, I am assuming that the voltage is V2 here. That means the V2 will be small I into R of 2. That means again you will get directly, we have to paste this value here. That means R1 divided by R1 plus R2 into R2 into capital I. This is my value of V2. That means we have applied two homogeneities individually, when the V will act as well as when I will act individually. And now with the additivity principle we know, that means the output, the final output must have to be summation of these individual results. That means I can apply the additivity now. Now with the additivity principle, we know that the total output will be summation of the individual outputs. That means the first output is this. Just write this, the R2 divided by R1 plus R2 into V plus the individual output of this is this. That means R1 R2 divided by R1 plus R2 into I, and this is my total response V. That means I will start with the homogeneity and I will end up with the additivity. This is my entire the superposition principle procedure. I will act one source at a time and I will calculate the response correspondingly individually, and at the last I will add all the individual outputs with the additivity principle. Now, here we will apply the superposition in this very simple circuit. Now, the case first, that means we have to calculate the voltage here. That means we will start with the voltage source when the 6 volt source is active. That means I will replace this current source with internal impedance. The circuit will look like this. 6 volt, 8, and this will become 4, and this source will act as an open circuit because it is 4, it is 8, and this is my 6 volt, and I want to know the potential across this. I am saying that it is my V dash, that means V first. Now what I have done, I will active this and I will replace this, and I will apply the method of analysis, and here both the resistance are in series. That means I can apply the voltage division rule. That means 4 divided by 12 into 6. That means the voltage will be 2 volts. That means my V1 is equals to 2 volts, where only 6 volt will act. Now I will replace again this 6 volt with internal impedance. That means on that case, in this case, my circuit will look like this. Short circuited, 8, 4, and here I have my current source of 3 ampere. And I want to know potential here, it is 4 and it is 8. That means I can apply, these two resistances are in parallel. I can apply the current division rule here. And here the resistance is double, that means the current will be half. That means the 2 ampere will go here and the 1 ampere will go here. Now here, resistance is half, that means the current must have to be double. And the potential will be 4 into 2. That means the V dash will be 4 into, not V dash, V2 will be 4 into 2, that means the value is 8 volts. And developed polarity is same in both the cases, that means the plus minus, all the time you will get the same polarity. That means the V, total V will be V1 plus V2. That means the value will be 10 volts. Or if you want to justify whether are you getting the right answer or not, just apply directly the KCL here and calculate the response when both the sources are acting together. Are you getting the same 10 volts or not? Now apply the KCL here. That means I will assume that the voltage is V dash at this node and here the value is grounded. That means not V dash, only V. V minus 6 by 8 plus V by 4 is equals to 3. That means V 1 by 8 plus 1 by 4 is equals to 3 plus 3 by 4. And whenever you will solve for this, you will get V is equals to 10 volts. That means you have seen that in the previous numerical, as you will apply the superposition, you are getting the same answer as your KCL. That means whenever you will add the response individually or when you will calculate the total response, you are getting the same answer in both the cases. The main advantage of the superposition will start when we will have more than one source of different frequencies. Because whenever you replace this, the value is j omega L. But if two sources are acting together across the source, then what should value you will choose to decide this omega? Because if you have more than one source of different frequencies, you will be in doubt which value I have to choose. That means this is the critical case whenever you will use the sources of different frequencies at a time in the circuit. Do not have any other option rather than the superposition principle, and this is the beauty of the superposition. That means whenever in any circuit you have more than one frequency sources, you do not have any other option rather than superposition. You have seen in the DC, whatever the numerical we have done here, that means no significantly use you have seen in the DC. That means when all the sources are acting on a particular same frequency, the superposition does not have any significant meaning. But whenever you will see the source of multiple frequencies are present in the circuit, you don't have any other option rather than the superposition principle. That is why this is so much important in the AC circuits. Because in the AC circuits, you will see a lot of sources of different frequencies are acting together on the circuit. Now, this is the AC circuit where the two sources are acting together in a circuit, and we have to calculate the RMS value of I. That means we have to calculate the RMS value of I. That means firstly we have to calculate the response with respect to each and every source. Now see the problem here. If both sources will act at a time, then how can you analyze? Because whenever you replace the circuit into frequency domain or in the complex domain, j omega L, then how to choose this? If both the sources will act together, then how can you analyze this? It is impossible to analyze when both the sources will act together here. That is why the superposition have meaningful, significant response in the AC circuits. That means the first case, when DC source is active. That means I will replace this particular source. That means my circuit will look like a short circuit, and here I will get the voltage of 8 volts, and here 1, and here I will replace this by j omega L. L value is 1, and here see DC, and DC have the frequency of 0. That means here you will get 0, and unit is ohm, and here the value is unit. 0 ohm means this is basically the short circuited, and I want to calculate the current I1, because when 8 volt DC is working, that means the I1 is equals to 8 divided by the total resistance is 1, that means the 8 ampere. That means I got one thing, I1 is equals to 8 ampere. Now I will add the second one and I will replace this by internal impedance. Now what will happen when the AC source will act? Now I will redraw the circuit again. Now I will short this 8 volts and I will act this AC source 12 sine t. Now here I can see that the operating frequency of this sinusoidal source is 1 radian per second. That means J, omega value is 1 and L value is also 1. That means it is totally J and the resistor value is 1 ohm. J ohm and 1 ohm. Now I can calculate this, but I want to, firstly we will do like this. That means the 12 sine t divided by 1 plus j. That means we have to calculate here the total value. That means 12 divided by root 2 sine t minus 45 degree. Because the magnitude of this number 1 upon 1 plus j, this particular number have the magnitude of root 2 and angle is minus 45 degree. That is why we will get this. This is my current I2. That means my total number of the current will be like this. That means I have applied the homogeneity here. Now I will apply the additivity principle. That means the total I will be I1 plus I2. I1 is 8 plus I2 is something like this. 12 divided by root 2 sine t minus 45 degree. And this is my total I. But they are not asking the value of I. That means after this you have to follow the superposition, and after this you should know how to calculate the RMS value of the composite function. That means up to here the superposition is over. After this you just have to calculate the RMS value of the function. That means the RMS value of this will be 8 square plus, what is the RMS value of this? That means RMS of first function into a square. That means what is the RMS value of this? 12 divided by root 2 divided by root 2 whole square. That means if you have the function Vm sine omega t, the RMS value of this function will be Vm by root 2. Same thing I have applied here. From here you will get root over 8 square plus 6 square. The value is 10 ampere. That means the RMS value of this current I is 10 ampere. But how can you calculate this RMS value if you are not getting the value of this? And to get this, the superposition you have to apply. You don't have any other option rather than the superposition principle. Now here, this is the question of the AC analysis where two sources are acting. This is first source, this is the second source whose operating frequency is not same. That means again, you don't have any other option rather than superposition to solve this particular question. That means across these terminals you have applied this combination of two sources and you have to calculate the response across this terminal. That means again we will use the superposition principle here. Firstly we will act this particular source and we will inactive this, and in the second attempt we will active this and we will inactive this. That means the first case when 2 cos 200t is acting, and I am assuming that my response will be V01. That means we will calculate all the impedances here. That means we have to calculate all the impedances with respect to this particular frequency. That means we will calculate the j omega L here 1 upon j omega c here, j omega L here, and 1 upon j omega c here, with this particular frequency where the omega is equals to 200. As we will put here the 200, we will get j50 here and minus j50 here. You will get j80 here and minus j500 here. But what will happen here? Plus j50 and minus j50. That means the total addition is 0. That means here, in this case, you will get the short circuit from here to here. Because whenever you will add these two numbers, plus j50 and minus j50, you will get the addition is 0. That means the short circuited. You will get the short circuit path from here to here. That means both have the same potential. That means whatever the potential you will apply here, you will get the exact potential here, irrespective of this branch. Because definitely you will get some combination, parallel combination of 80 and minus j500 plus series with 2. But I am not interested on that because I am getting the short circuit path from here to here directly. That means V01 will be the voltage here itself. That means 2 cos 200t, you will get exact output because this is my output terminal which is sorted with my input terminal. Now my second case will be when this source will active when 500t source will active, that is a radian, 500 radian per second is my operating frequency of this particular source. On that case, I will calculate all the impedances again. That means my second case will be when 4 sine 500t is active. This is my second case and my output will be V02. On this iteration, whenever you will put this value here, that means omega value is 500. Whenever you will put here, here, here and here, you will get the values like J125 minus J20, and here you will get J200 and minus J200 minus J200. All the unit have ohm. But what will happen here? J200 and minus J200. That means the parallel combination of J200 and minus J200. That means J200 into minus J200 divided by 200 minus J200. That means the equivalent Z of this particular branch up to parallel combination of these two is infinity. What is the meaning of this? That means you are getting the open circuited combination here. That means you have a freedom to replace this. That means it will act as an open circuit. Now see, if it is open circuited, that means no current will flow in this particular loop. That means whatever the potential you have here, no drop will happen here. In this case, this is not short circuited. That means whatever the potential you have here, the exact potential you will get here. That means again, in the V02t, you will get exact power supply again. That means the value is 4 sine 500t. That means homogeneity I have applied. With the first source I got this, with the second source I got this. Now I will use the additivity principle and I will add both the things. That means my V0 will be V01 plus V02. That is again I will get the V0 is equals to Vi of t, because I have added these two functions together. That means this is my output. That means whatever the input I have, I will get as my output. Do you think is it possible without using the superposition principle? We cannot solve this particular problem without superposition. That is why the superposition has significant meaning in the AC sources. We will discuss the limitation of the superposition principle. That means where the superposition principle will get violated or where we cannot use the superposition. Superposition is not applicable everywhere. That means we have to see those case conditions also. Otherwise, we will do the mistake. That means we will solve those questions only which are not possible with the superposition. That means This question we have discussed already. That means with the 6 volt we will get this 2 volt here. With this 3 ampere we will get this 8 volt here, and the total voltage is 8 volt. But assume if I will ask the power here, and you will calculate the power with V1, V2 and V. Now that means I will calculate the power individually first, and then I will apply the power with the final value. That means when the value is V1, what is the power? That means the P1 will be V1 square divided by 4. P2 will be V2 square divided by 4, and the P total will be V square divided by 4. Whenever you will apply the first one, you will get 1 watt. Whenever you will apply the second one, that is 64 divided by 4, that means 16. That means the addition of P is equals to P1 plus P2. If you will apply the homogeneity here, what will happen? You will get 17 watts. The total power, if you will apply the homogeneity with respect to first component with respect to second component. But what will happen here? That means 100 divided by 4. The value is 25 watts. What is happening? The additivity is showing 17. That means with the superposition principle if you will apply, and here you are getting 25 watts. Ambiguity is happening here. That means you cannot calculate the power with the superposition principle individually. That means you will calculate the power with respect to first source individually. With respect to second source, you do not have freedom to do this by the superposition. Why? Because the power is not linear function with respect to voltage and current. What is the power? V square by 4. That means it is parabolic function which is not linear in nature. That means you cannot calculate the power with superposition principle. If you want to apply the superposition, firstly calculate the voltage, because you can calculate the voltage only with respect to superposition principle. Then after that, calculate the power with respect to the final voltage, because you can apply the superposition only to get the final value of the voltage, not the power. Now, we will discuss the second condition where my superposition will get violated, where the superposition is not applicable. Now, take this particular combination where this 5 volt and 5 volt in parallel, and with the parallel with the 5 volt and 5 ohm combination you have. Okay, and we have to calculate the current here I with respect to superposition principle. Now, draw the circuit when I am saying it is the first source and it is my second source. That means with this 5 volt will active and you will inactive this with respect to internal impedance. What will happen? You will draw like this. 5 volt short circuited, and then you will get here the 5 ohm. That means the current here will be 0, because the current will follow only the least resistance path. That means here you will get 0 ampere. Because the entire current will flow from here, and that value is very high. Okay, that means as I am saying it is I1. Now if you will active the second source, what will happen? Whenever this 2 is acting, that means first one is short circuited, second time you will get something like this, and here like this. That means it is 5, and here again the current will be 0, because you are getting another short circuit here. That means the I2 will be also 0. But whenever you will add here the additivity principle, that means the I is equals to I1 plus I2 is equals to 0 ampere. But if you will apply the method of analysis here, the voltage difference is 5 and the value is 5. That means the actual value of the current is 1 ampere. Ambiguity again. Here with the superposition you are getting 0 ampere. With the actual method of analysis you are getting 1 ampere, which are not correct. Why it is happening? Because if this 5 volt had decided that the potential across these two terminals are 5 volt, then what this other voltage source is doing here? That means this is basically the redundant source. That means if you have any redundant source in the network, you cannot apply the superposition principle. That means two parallel voltage sources are not eligible to apply the superposition principle in the network. That means you not have freedom to put two voltage sources in parallel. Otherwise, the superposition will get violated. We will take another case. Instead of voltage, if I will apply two current sources in series. Now, here we have this type of arrangement. I am asking what is the loop current here, or calculate the voltage here. What is the voltage here? That across the 5 ohm. But whenever you will apply the superposition here, if I am saying this is my source 1 and this is my source 2. That means when the source 1 will active, I am saying that this is my V. When the source 1 will active, I am claiming that it is my V1. That means when that will active, what will happen? Here the 2 volt will be, 2 ampere will be here. And here you will replace by internal impedance, which is infinity. That means you are creating the open circuit here. That means the current here will be I is 1 is equals to 0. That means the V1 you will get 0 volt because no current. V is equals to IR, current is 0, that means the voltage will be 0. Now, what will happen if you will replace this particular source? That means I will replace this and I will active this. Now, what will happen? Now, in this case also, you will get I2 is equals to 0. That means the V2 will be 0. That means the total value V is equals to V1 plus V2 is equals to 0 volt. But if you will apply the actual method of analysis, the current is 2 in this loop. That means the voltage V will be 5 into 2 is equals to 10 volts. What is happening here? Again, the actual voltage is 10 volt, but you are getting here 0 volt. What is the meaning of this? If this particular first source are decided that the loop current or the mesh current is 2 ampere, then what this source is doing here? Okay, that means again at this time, this is my redundant source. That means whenever the redundant source will present in the circuit, you cannot apply the superposition. That means we got 3 important points from the superposition. The first one is all components must have to be linear, otherwise you cannot apply the superposition. The second one, any redundant source should not present in my circuit. The third one, we cannot calculate power from my superposition principle. These are the 3 important points or the extreme points where my superposition will get violated. And very more useful point is, whenever more than one frequency source will present in the circuit, we don't have any other option rather than superposition principle, and that is the beauty of the superposition. Thank you. It's all about superposition.